Hello everyone, welcome back to Math Hub by Mr. H. And in this video, you will learn about writing a flowchart proof about congruent triangles. Alright, but before we jump straight into writing proofs, let's recall some postulates and theorem that we will use in writing proof. So the first postulate is what we call the side-side-side congruence postulate, which states that if all three sides of one triangle are congruent to the corresponding three sides of another triangle, then the two triangles are congruent. So you can see the diagram right here. And also the marking. So that means that this side PQ, right, and side ST, they are congruent, corresponding congruent sides. Same goes for the other two pairs. So in proving congruent triangles, we only need three congruent statements. Definitely we can say that the two triangles are congruent. All right, so going back to this triangle, we can say that segment PQ is congruent to segment ST. The second pair is segment PR is congruent to segment SR. And the third pair is we have segment QR is congruent to segment TR, right? So we can say that the two triangles are congruent by using all these information, and they are proven using the side-side-side congruence postulate. All right, so let's take a look at the second postulate, side angle side congruence postulate, which states that if the two sides and an included angle of one triangle are congruent to the corresponding two sides and an included angle of another triangle, then the two triangles are congruent. So we need to take note here, two sides and an included angle. So when you say included angle, so this is an angle formed between the two sides. So if you take a look at the diagram below, so we have here included angle here. Let me highlight in yellow. So that one. And also this angle Y. All right, because as you can see from here, the sides that are being linked together by this angle are highlighted. They are congruent, corresponding congruent sides. So you can see side, angle, and then side. This one is side, angle, and then side. So there's no jump, all right? So that's how you read the markings, and that's how you identify which postulate is used to prove that the two triangles are congruent. So the third one is what we call the ASA congruence postulate, or angle side angle, which states that if the two angles and the included side of one triangle are congruent to the corresponding two angles and the included side of another triangle, then the two triangles are congruent. So here we're talking about two angles and included side. So you can see here the included side. So included side is the side that's linking the two angles highlighted there that are congruent. Okay, so if we're going to write some statements from the given figure, so we can say that angle RPQ is congruent to angle ZXY. Okay, so this is angle. And for the side, we're looking at segment BQ is congruent to segment xy. So that's the side. All right, so for the third statement, to complete the proof, we have angle RQP is congruent to angle ZYX. Right, so that's another angle. This way it's ASA. All right, so just be careful because the statements can be written not in order. All right, but then in order for you to know which postulate is used, you need to base it on the markings. All right, so let's take a look at the last one, which is what we call a theorem. So we call it the AAS congruence theorem, or angle side. It states that if the two angles and a non-included side of one triangle are congruent to the corresponding two angles and a non-included side of another triangle, then the two triangles are congruent. So take note of two angles and non-included side. So when you say non-included side, this is not in between the two angles. So this side that is highlighted, that is not linking the two angles together. If you can see here the diagram, so I'm highlighting this marking. This side is a non-included side. Why? Because you have this angle J and angle M that are congruent, corresponding congruent, and there's also another one, which is this one. So angle JKL and angle MKT, they're congruent as well, vertical angles. That's why by looking at the markings, so you'll have angle, side, or you can say side, angle, it's okay. AAS or SAA. Same goes for this one. You have angle, side. All right, so we're going to be using these postulates and theorem as well as your knowledge of different geometric terms and definition of terms and stuff like that that you've studied prior in writing proof. So let's take a look at the first example. So the given statements are segment DR bisects segment QF. Segment DR is this line. And it says it bisects or cuts QF. This is QF. So when something is bisected or cut, definitely the line or the segment that is cut or bisected will be equal in length. So that means that QE is congruent or equal in measure with FE, all right? The second statement we were given, segment RQ is perpendicular. So the symbol perpendicular to QF. So when you see the symbol perpendicular, what is special about it? It means that the two segments can be two lines or two segments. They intersect and form a right angle or a 90-degree angle. So that's what's special about perpendicular lines. So that means that this angle is a right angle. So that's for the second statement. And for the third statement, DF is perpendicular to FQ. That means that this angle is 90 degrees. All right. So once you are presented with the given statements, what you need to do is to label or mark the diagram based on the given statements. All right? Because later on, when you identify the postulate or theorem that is used to prove that the two triangles are congruent, definitely you will be using the markings on the diagram. All right, so let's start writing our flowchart proof. Let's start with the very first statement. So we were given segment DR bisects QF. Okay, so remember to put it in a box and you write the reason below the box. So that's given because that's a given statement. And then from this statement, we were able to derive a true statement, which is segment QE is congruent to segment FE. So what we're writing below is the reason or the definition that we used, how this statement was derived. So it's also possible that you can write this whole thing here, right? Because this statement actually came from here. That's also okay. But there's other options. Like since the keyword that's used here is bisect, definitely you can use that to write a reason here. For example, definition of segment bisector. So the next thing is the second statement we were given. So it's going to be different line because that is not connected to this two, right? So segment RQ is perpendicular to segment QF and write the reason given. And from that statement, we were able to derive another statement, which is angle RQE equals to 90 degrees. So right angle. For the reason, you can write here either this statement or you can write definition of perpendicularity. And for the second one, segment DF is perpendicular to segment FQ, and then given. And from there, we were able to write another statement, which is angle DFE is equal to 90 degrees. Definition of perpendicularity. So remember earlier I mentioned that we need 3 congruent statements to be able to finally write a conclusion that the two triangles are congruent. Yeah? So far we only have one, right? Which is this one. So we need 2 more. If we use these two statements about perpendicularity, looking at the diagram as well, this angle, which is 90 degrees, and that angle, which is also 90 degrees, they are congruent, right? So basically, we can use that. So by linking these two perpendicularity statements, we can write another statement from there, which is angle RQE is congruent to angle DFE, and the reason is all right angles are congruent. I hope you understand my writing. So we have 2 statements now. We need 1 more. And where is that last statement gonna come from? We need to go back to the diagram here. Which do you think is the last piece of information that we need for us to conclude that the two triangles are congruent? All right, so if you're thinking about this, then you are right. So this angle right here, those are vertical angles, and those angles are congruent all the time. I need to write it on a different line because it's not connected to the other or the previous statements, okay? So I would say that angle REQ is congruent to angle DEF, and the reason is vertical angles are congruent. You can also write vertical angles theorem. This is actually the third statement that we need. So since we already got 3 congruent statements, then we can write a conclusion. And to complete the flowchart proof, so we need this, the first one, we need the second one, and we need the third one, right? And then using those 3 statements, we copy the proof statement. Triangle REQ is congruent to triangle DEF. And we go back to the diagram. So which postulate or theorem is used? Look at the flow. So we got angle, side, angle. Angle, side, angle. So that means the postulate used is ASA. Alright, so this is the complete flowchart proof. And if you find this question interesting to you, so hit the like button and subscribe.